Hey, what's up guys? My name is the Cherno, doing all this again. I was gonna not do that for the year, but it's just who I am. Welcome to another one of these 1 hour challenge videos where we are going to do something in 1 hour. Yeah, it's the only way I get anything done is if I set myself a good timer, you know, for an hour. So as you can see, we are back here in the office. You've probably seen a little bit of this set before. I say set as if this is like a film set, but it's just my office. And the reason we are here today is because this is my desktop computer, this is my primary work environment, and this is all an effort to get you guys a little bit more involved with what I do. I want to actually start making more videos of just kind of day-to-day programming or work that I end up doing and kind of involve you guys more in that. So the fact that there is a camera now set up behind my computer monitor looking right at me, and my monitor's here and my keyboard is here and all of that stuff means that hopefully, no guarantees, but maybe, just maybe, I'll make more videos. Man, doing YouTube full time is actually kind of challenging, you know? Okay, so enough talking. What are we doing here today? Well, I thought it would be a good idea, since the topic of this channel has somewhat been batch rendering lately, for us to actually sit down and write a complete batch renderer within an hour. Just to show that, first of all, even though we have a lot of these videos and they go into details, and it's me kind of talking a lot about how, why we make decisions and actually showing you guys how to make everything step by step. The actual, at the end of the day, the actual programming part of this is not that complicated. It's definitely possible to write a kind of basic batch renderer within an hour, as I'm going to prove here today. And this is going to be kind of fully featured, so to speak. I mean, I'm sure that there's going to be improvements that I'm going to have to make to it because it's an hour. But still, at the end of the day, I actually want kind of a working batch renderer that I can throw any amount of kind of geometry at it and it will figure out what to do with it. I want to be able to render quads of different colors as well as different textures. I basically want to come out with something that's going to be usable by the end of this, and that is the plan for today. But first, I want to thank Hostinger for sponsoring this video. Now, Hostinger have been a great sponsor this past month, sponsoring so many videos, and the reason why I love that is because they're just good. I like Hostinger. The actual product that they have is not just some other product that I'm just advertising because I want the money. No, Hostinger is actually a product that I believe in. It's something that I like to use because it's just a really easy to use, fully featured web hosting platform that is extremely affordable as well. Now, I strongly believe that pretty much everyone should have a website, because a website, it's kind of like your online presence. You can't really control social media profiles as well as you'd like. I mean, you can make a YouTube channel, you can make an Instagram page, but it's still not going to give you as much control as if you sit down and make your own website. You could link all of your social media there in one place. You can have all of your projects there. You can treat it as a custom blog platform and just write about whatever it is you want to write about. And at the very least, you can have a professional place on the internet to actually hold information about you, which is really important if you're looking for a job or just looking to network with people. And the reason why Hostinger specifically is such a great web host is because their platform is extremely intuitive and easy to use. Apart from the UI just being extremely clean and simple and easy to use, it also has built-in diagnostics that will help you diagnose problems with your actual setup. The other thing that I love about Hostinger is that it's extremely affordable, but it doesn't sacrifice quality to get there. It's not just a cheap web host. Cheap in the sense that it's not good. Hostinger manages to stay affordable whilst also giving me all the features that I need in a very well presented package. And for that, I honestly cannot find a better choice of web host. So if you guys are interested in Hostinger, check the link in the description below. If you use code Cherno, Hostinger have been awesome enough to give you up to 91% off web hosting plans. Huge thank you again to Hostinger for being such a lovely sponsor this month. Let's get on with this batch rendering challenge. You know, secretly, these challenges are actually extremely helpful. I feel that challenging myself to actually do something within a time limit is a really good way to practice both my programming skills, but also, I guess, my thinking skills. Sitting down and actually having to work through a problem in a finite time is a really good exercise, I think, for pretty much everyone, because the fact that you have that finite time means that you don't have to put this off as oh, I don't have time to do this, because you've given yourself a time limit. It's 1 hour. It's not going to take over your whole evening or your whole day or something like this, because, you know, I've done these challenges in the past. Obviously, I made a particle system in an hour. Check out that video if you haven't already. That was such a smooth plug. I can't even mention a video I've done without being check that video out. Anyway, whatever, YouTube alive. With the particle system video, I knew that I could easily spend a whole day writing a particle system. I mean, you can definitely take it slow, you can keep adding features, you can test it out with different things, you can just play around with it as like a sandbox of fun particles everywhere. Like, you could play with that stuff for hours, but the fact that I had to do this within an hour, and I had to set a timer, and I had to actually work there kind of in front of the camera and get all of that stuff done, that, I think, is just a really cool experience. So the fact that you guys watching are probably not YouTubers, that doesn't matter. Me and you know, we're both people, we're both likely programmers. Sit down and try and do this challenge along with me. It doesn't have to be a batch rendering challenge because you might not know how to write a batch renderer, and of course that's totally fine. Come up with something that you know that you most likely can do. Maybe even if it's something that you're not 100% certain you have the necessary skills or experience to pull off, still sit down and actually try and give yourself a time limit and work on something as fast as you can. Apart from the fact that you're basically guaranteed to improve in that area, you'll also have a ton of fun and likely come out with something that you can then maybe improve in the future. All right, I think I'm ready. My wife and I are planning to go out for dinner. We're gonna grab some dumplings afterwards, so that should be motivation enough for me to sit down and get this done. Let's do this batch renderer. And just like with the particle system, I'm gonna give you guys a post-mortem of how it went rather than trying to kind of show me making it, because I think this is gonna be a lot more useful. So what you're seeing here on screen now is just the result. I'm gonna kind of take you guys through the code in a minute live. All of this is based on the batch rendering series that I currently have going on my channel. Hello, Mike, by the way. So if you guys haven't checked that out, and if you want to know how all of this works, then I would really encourage you to check out that series. There'll be a link up there because that's gonna take you through how batch rendering works and how to actually put it together. Whereas this is just gonna be a fairly quick overview of how I actually wrote a complete batch renderer within an hour. So let's check it out. So obviously with this being done like within an hour, and I think it took me right about an hour. I mean, to be completely honest with you guys, I didn't actually end up timing this, but judging by the time, like it's 5 o'clock now, I started at 4 o'clock. It's been an hour. I think with me having done these challenges now, it's really interesting to reflect and look at the fact that work really does kind of expand to fill the time that you have allocated for it. If I allocated 2 weeks for a batch renderer, I think it probably would have taken me 2 weeks. But with this having like just having 1 hour to do this whole thing, the fact that I had set this arbitrary time limit for myself, and obviously the fact that I looked at the time every now and then, means that it took me pretty much exactly an hour. I think that if I had set an hour and a half, it would have taken that long. If I had set 45 minutes, I think I could do it in 45 minutes. But with that 1 hour time limit, it just ended up taking 1 hour. So that's super interesting. All right, so we have this kind of scene here. I like to do this kind of grid thing here. It's a little bit difficult to see all the individual quads that are being rendered. However, there are 6,426 different quads, and as you can see in this IMGUI panel, all of that is inside one draw call. We have a variety of colors here, as well as 2 different textures. Now, theoretically, this system could support up to 31 textures. However, I did not bother loading 31 different textures, especially within an hour, because I feel like that would have taken like an hour to set up. So I only have this Cherno logo and the Hazel logo, but that's okay. I think that if anyone wants to test this out themselves, then they can absolutely do so. I believe that it should work. And as always, I'll have the link to the code in the description below. So if you want to download this code, if you want to play around with it yourself, then just check the link in the description below. Usually I kind of get these videos out as soon as possible and then maybe upload the code the next day. So if it's not there, make sure you check back in the future. And just to kind of demonstrate this actually being dynamic, we also have this quad position that we can control. So we can basically control the position of this quad. It's all in one batch though. And theoretically, like, I mean, all of these quads are being resubmitted every single frame. So they are completely dynamic, and making them all move randomly, for example, would be a trivial change. Now, as I mentioned, we do have 6,400 quads here in one draw call, because the maximum quads per draw I've set to be 10,000. Now, the way that I've written this renderer, as we'll see in a minute, means that I can easily kind of change that. I can just make this only have 1,000 max quad count, which means that only 1,000 quads can be drawn in a single draw call. And if I relaunch this and we take a look at what that looks like, you can see that now we have 7 draws. So we have 7 draws making up this scene. It looks the same, it still performs well, obviously, But all in all, we have 7 draw calls instead of the one that we had when our limit was 10,000. Okay, let's dive in and take a look at the code. Now, I do want to be quite brief here. I'm not going to cover things like this load texture function because I think that's self-explanatory. The code base that I started with, by the way, is the OpenGL base library. I've made a video about that you can check out, and also download the base library for yourself and kind of start on that. But essentially what I did was I started with the base of the last batch rendering video that I put out. Now, as of me recording this video, I haven't done the index buffer video yet. So the last video was actually the dynamic geometry video. So that's kind of the base that I started with. And then from there, I mean, I had to wipe most of that clean, but I had, like, for example, the textures already loaded and I had the shader already loaded, but I had to modify the shader, as you'll see in a minute anyway. So that was kind of the base that I started off with. And then I basically started by creating this renderer class here and then just filling all of that out. So let's start with the design and architecture of this whole thing. First of all, this is a completely static class. There's absolutely no members whatsoever here. What I've done is just essentially used class as like a namespace kind of to group things together. This is just something that I like doing. It's not a singleton at all because there is no instance of renderer ever. So don't be fooled into thinking that that's the case because it's not. We have an init function, a shutdown function, and then kind of the meat of the system behind this, which is the begin and batch and also the flush function. And then this is how we can draw quads. The draw quad function simply takes in a vec2 position, a vec2 size, and then a vec4 color or a texture ID. So you can either draw a flat colored quad or you can draw a textured quad. We also have some stats here. This is purely for the IMGUI panel that shows how many draws we have and how many quads we have. That's all it does. It's not actually used by the system whatsoever. Okay, let's take a look at all of this code. So with it being a static class, what I've done is defined a struct here called renderer data. Now this, again, could be any kind of data structure that you want. I mean, you could just have these as variables inside a namespace. You could just have them as static variables. I like making a little struct called renderer data and then making a static kind of instance of this. I mean, it's not statically inside a class. It's just static inside this translation unit, meaning that it's kind of internal to this translation unit. But basically, this is like some static storage that will contain all of the data that we actually need for this renderer. Up here, I've also got a few constants that basically define the max quad count, the max vertex count, index count, and how many textures we can have. Now, a few things to note is that at the moment, I've written this as 32 because I know that the platform that I'm on has at least 32 texture slots. However, what you would probably want to do in a more serious setting in which you're not writing this within an hour is query the driver to find out how many texture slots you actually have. Now, I did say earlier that we support 31 textures. That's because one of the textures is reserved by the renderer for something, as we'll see in the future. So in the renderer data, we basically hold OpenGL identifiers for things that we actually need. So these are all the IDs for the vertex array, the vertex buffer, and the index buffer. We also have this special white texture, which I will talk about in a minute. Index count is how many indices we need to draw when we actually flush. Then we have 2 raw pointers here, one of which is basically a base pointer to the beginning of the quad buffer, which is a CPU side buffer that contains all of our vertex data. And then we have this kind of quad buffer pointer variable, which is basically where we're up to when we're copying data into this quad buffer. We also have an array of texture slots here. So this is basically holding which texture slot maps to what OpenGL texture ID. So it's kind of like a map. I mean, it doesn't need to be a map. It's a stack-based array here because the key is just the index of this array. And we'll see that in use in a minute. Texture slot index is what index we can put our next texture into. And then we have some stats here. So what do we do when we initialize the renderer? Well, the first thing we do is actually allocate memory. So this quad buffer, as I mentioned, is just this raw pointer here, which contains our CPU side storage for our vertex buffer. So during each frame, what we want to do is basically put data into that vertex buffer that is on our CPU side. And so anytime we want to render a quad, we simply copy the vertex data that we create and copy the vertex data that we want into this kind of buffer that we hold on the CPU in C++. And then at the end of that batch, we want to flush that data. So what we do is we copy it onto our GPU into OpenGL, and then we execute a draw call. So this kind of quad buffer is our CPU side storage for all of those vertices. Now, before some of you get upset with me for using new here, let me just explain why I'm using this. So the lifetime of this memory is very simple. When we start up the renderer using init, we allocate the memory for this quad buffer once. And then if we go over here in the shutdown function, we free that memory. It's very simple. We have our init and we have our shutdown. The memory is explicitly controlled by these two functions. If you are stupid and you call init twice in a row, for example, then yes, you will probably get a memory leak, amongst other things like creating extra vertex arrays in OpenGL and not deleting the previous ones and losing references to it. Anyway, basically you should not call init twice. And a really easy way to ensure that you don't is simply to assert or return or do something if you notice, for example, that quad buffer is not null pointer and you're calling this, because if it's not null pointer, then, well, clearly something has set it and clearly something has called init before. But anyway, the way that we use this quad buffer is as a pointer to copy memory into. If it was a smart pointer, it would be quite a hindrance to actually retrieve the raw pointer from that smart pointer and then actually copy data into that memory location. It's a lot easier to deal with this if it's just a raw pointer, as you'll see throughout this class. So to summarize, yes, you could technically make this like a unique pointer or something like that, but it would be a complete hindrance. And also, technically speaking, you would have to manually somehow free it or reset it inside shutdown, which kind of defeats the purpose. So yeah, don't hate the raw pointers. So moving on, now we create our vertex arrays, which is fairly straightforward. We create a vertex buffer with the max vertex count. Now the vertex itself is a little struct here that defines what our vertex looks like. We have a position, a color, texture coordinates, and a texture index. We set up all the vertex attributes here so that OpenGL knows what our layout is. And of course, we don't actually copy any data to begin with into this vertex buffer. We just mark it as dynamic, and then we do that every frame. Next, we set up the index buffer. So this is just kind of the pattern of 0, 1, 2, 2, 3, 0 plus whatever offset we're up to. Just a little for loop that will go all the way up to max index count to actually fill our index buffer with our predictable indices. And then we, of course, send them to the GPU here. And then finally, we have this kind of 1x1 white texture. What this is, and I actually talked about this in the game engine series. I think I have a video, I'm not sure what it's called, but I'll link it up there that will probably explain this a little bit in a little bit more detail. But essentially what this is just literally a 1x1 pixel white texture that essentially acts as no texture at all. And this is good because we can basically just have a shader with no branches or anything like that can render both a textured quad and just a flat colored quad. Because if we don't want a texture, we just use this texture, which is white, meaning that if we multiply it with any color, it will not affect the color that we're trying to render. Then we set it as texture slot 0. So in other words, the first texture, the texture at texture slot 0 is this white texture. Then we have this little for loop in which we go through all of our texture slots and just set them to 0. That's just a little bit of like a mem clear. I could have just used a mem set, honestly, but that's the way that this works. Now shutdown deletes everything except for awkwardly does not delete the texture because, well, I forgot to do that. Let's just shove that under the rug. Let's not say anything to me taking more than 1 hour to write this renderer, please. And that's pretty much all of the initialization and shutdown code that we have. Okay, let's get into how we can use this renderer. Well, because it kind of was 1 hour, it's not completely self-contained. We still have a shader that we actually set up here, and also a whole bunch of samplers that we set in that shader, because the shader I didn't actually integrate into the renderer. If I had had more time, that is probably something that I would have done. But this way, the client kind of has control over the exact shader that's used and all of that. So it does have its benefits, but essentially what we need to do here is set up a uniform and set all 32 samplers that we actually have. So if we take a look at the shader quickly, the vertex shader is super simple, just takes in a bunch of vertex attributes and forwards them into the fragment shader, as well as setting the GL position to something that you would expect. And the fragment shader has this uniform sampler array, which has 32 sampler 2Ds, which are our textures. We then retrieve the index of the texture that we want to render for this quad or for this fragment. And then we set our output color to be that texture. We're sampling from that texture and multiplying with our vertex color. So the way that this works is pretty simple. If you're rendering a textured quad, color is set to 1, meaning that you just multiply the texture sample with 1, meaning it does nothing. And then vice versa, if you're rendering a colored quad, then this texture is that 1x1 white texture, and then you multiply that with the actual color that you want. So thus the texture lookup does nothing, and you're just left with your desired color. So that's our quick tour of the shaders. Moving on. So this is us setting the samplers to just an ascending value 0 through 31. Then we initialize the renderer and we also shut it down on the detach function here. We load our textures as we did in that batch rendering series. And then we can scroll down into on update and actually use this renderer. We reset the stats at the beginning of the frame and then we begin all of this lovely rendering. So begin batch will begin the batch. Big surprise. This is pretty simple. All it does is just reset this pointer to the beginning. So this pointer keeps track of where we're currently copying data to in the CPU side vertex buffer. So in other words, if we want to render another quad in our batch, we need to actually copy all the vertex data into a specific point in that buffer. And this pointer keeps track of where we're up to so that we can copy data into that location. At the beginning of the batch though, we obviously reset this to the beginning of the buffer because we need to now overwrite the previous frame's data with our new data. Going back into here, we have a for loop that renders all of these colored quads. This is pretty basic stuff. We basically just call draw quad. Now this takes in an X and Y position, which is just calculated from this for loop, a particular size here as well. So 0.25 is the size. I could easily make this not square or change the size. And in fact, if I do something like add a gap here, so I'll make the size slightly smaller than the spacing between these two quads. And now you should be able to see the quads a little bit better. Okay, so here they are. These are all of the individual quads being rendered, as you can see. This particular function we're calling is the color variant. Let's take a look at how that works. So the first thing we need to do is actually check to see if we have room inside our batch for more quads, because it's definitely possible that we get to the point where we have just run out of vertex buffer because we obviously have a maximum count up here. And if that's the case, if we have actually exhausted that buffer, we just basically need to reset everything. We just need to end the batch, flush what we have now, so meaning render what we have now as a draw and everything, and then just start a new batch. And then that's where everything else will go. So pretty simple stuff. Now, because this is the color variant, our texture index is simply 0, meaning it's that white texture. Because what we did up here is we set that 0 slot to be the white texture. So that's why it's specifically 0 that we set over here in our texture index. GPUs like floats, that's why we're using a float here and not an int, but that's just about the only reason. You could probably get away with using an int, that's fine as well. Then we just set up our vertex data. So you can see that we're copying all of this data right into the quad buffer pointer because that's pointing to our next kind of available storage space for our quad that we're trying to draw. We calculate and copy the position, color, texture coordinates, and texture index for every vertex that makes up this quad. And then we advance the index count by 6 because a quad, of course, is 6 indices. We also increment our little quad count variable here to keep track of our statistics. And that's pretty much it. Okay, so going back to our sandbox layer here, that is really it. And then we have a very similar looking setup here, but this renders textures, either the Cherno text or the Hazel text, depending on what iteration our for loop is up to here. This function is a little bit more involved because it has to deal with all of this texture slot stuff. So coming over here into draw quad, we have a similar check here, but we also check to see if we have enough texture slots to actually render this. Because again, if we're out of texture slots and we want to render more than like 31 textures, and the reason that it's 31 other textures is because one of them, of course, is this white texture. So since we're using that texture slot for the white texture, we have 31 available other texture slots for all of our textures that we want to render onto our quads. So if we are out of texture slots, then again, we just end the bash, flush, and begin again. Coming over here, we do have this color that is in fact just white because we're trying to draw a textured quad. We don't want any kind of color. Now, theoretically, of course, you could use this to tint the color of a texture because if I set this to a value other than white, it will in fact tint it, but I didn't add any kind of API to support that. So here we have our kind of texture slot mechanism. So what this does is tries to find if this texture has already been used for another quad. So in the example that I showed here, I was obviously reusing textures. I was using the Cherno texture many times here, as well as the Hazel texture. So clearly we don't need to keep kind of adding this into a texture slot and thus kind of taking up all of our texture slots. So what this for loop does is it iterates through all of our texture slots and sees if that texture ID of the texture that we're trying to use is already there. Because if it is, we can just grab that texture slot and we're all good. It's already been added as one of the textures that we want to render a quad with. Now this does kind of make make it a linear complexity, you might want to use something like a hash set maybe. I don't think it's that necessary though, because again, there are like 32 max texture slots. So it's not like you're going to iterate through 1,000 or more elements. It's really quite small. So I don't think that this is a problem whatsoever. Finally, if you didn't find it, right? So if the texture index is still 0, meaning it's that white texture, which means that that's clearly not valid because you probably want to render with your own texture here. So if that index is 0, we simply assign it to the texture slot index, which is the next available free texture slot index that is inside this array here. We then add this texture ID into the texture slots array at that index, and then we increment the index for the next texture slot. Then the rest is business as usual. We're now copying texture index instead of course, just a flat texture index of 0. And that's pretty much it. Index count plus equals 6 and those stats. And honestly, as you can see, that's all there is to it. It's a very simple batch renderer. It does everything you need. It's like 200 lines of code. If we go back into sandbox layer, you can see my usage of this. I then simply call end batch after rendering that kind of big Cherno text, whose position is also dynamically controlled by IamGUI here. Then I just end the batch and then I just flush. It's really as simple as that. I also set up these uniforms, but honestly, I don't know why this is here. It probably makes more sense to just put it over here after I actually enable my shader here. That's kind of it. That's the batch renderer. All right, so that's pretty much all there is to it. It's understandably pretty simple. It's one of the things that I love about these 1 hour challenges is the fact that, well, it's an hour. So the stuff you produce is going to be pretty simple and thus easy to explain and hopefully easy for you guys to understand and kind of learn new things. Now, I haven't spoken much about the performance of all of this and I'm aware of that. It's obviously something that I've just done in an hour. What I want to do in a future video is actually stress test this and also talk about some optimization strategies. Let me know in the comment section below if you want to see something like that. I'll probably work on that sometime next week or the week after. I also want to mention that if there's anything that I did not explain well, or if there's something that I just completely forgot to mention, then please let me know in the comment section below and I'll try to reply to you and we can kind of talk about it. Also, if there are any other 1 hour challenges or just challenges in general that you would love to see me do, then just drop a comment below. As I mentioned, I love doing these and I absolutely want to do more of this kind of stuff in the future. But until then, I do hope you guys enjoyed the video. If you did, please hit that like button, because that's what keeps me going here on YouTube. And also don't forget to check out Hostinger with that link and code in the description below. And if you'll excuse me, I am off to eat some beautiful dumplings with my beautiful wife. Goodbye.